Hi there. So today's video, this one is going to be about building a basic fixture system, specifically a standard fixed jaw vise. So don't be concerned about the fact that we have a 5-axis machine here. That's purely window dressing as far as this project goes. And we're going to very quickly take a look at setting up a Kurt vise. I downloaded the model for this vise from the Kurt website. It did take a little bit of editing because otherwise it's a step model with a lot of components, each individually listed, and obviously I don't want it to be too visually confusing for these videos. Anyway, so if we're going to build this vise, the first thing that we want to do is we need to actually import the model. So we're going to go into the model space and we'll click on fixtures, just for the sake of keeping everything tidy. And I am going to import this Kurt dx4.stp file. And now that we've got that imported, this all looks pretty good. It's a standard vise. There's only really so much one can say about it. So we're going to go into the machining space, and the first thing that we're going to do is we're actually going to hide this part. So let's turn all of that off. Right, okay, so all the fixtures turned on. And we're now going to go down to the fixtures tab. And we're presented with various options here. So I am actually going to add a vise since we're building this from scratch. It is worth noting, however, that there are pre-built example vices in this as well, along with chucks and standard toe clamps, which we'll go into developing our own in subsequent videos. But for now, we're going to click on Add Vise, and we're going to open this up, and we can see here that we have the body and the jaw predefined, but there's nothing in there. So I am going to double click on where it says empty, and you'll see that it opens up this document the STP file, which has got a document structure inside it. So I'm going to double click on that, and I'm going to click on body. Now, just to double check that it's exactly what it is that we want, I'm going to turn part visibility back on, and we can see that the section that is highlighted is the main body of the vise. So that's what we're after. So I'm going to click on add now, and that has suddenly come up in solid color. As I say, this is why I wanted to turn everything else off, because otherwise it would be overlapping with a grey instance of the same thing, which is far from ideal for this, because that becomes visually confusing quite fast. Now I will close this, and for the jaw I'm going to double click here. Now, due to the way that the file editing went, unfortunately the block naming didn't coherently copy through, so brep rep 1 is actually our jaw element. So I'm going to click on this now, and then I'm going to click on add here. Now we have, albeit embedded into the body of our 5-axis turntable, which is not really ideal, we'll resolve that in a second, but we do now have a very basic vise defined. We can, however, go a little bit further. We can set constraints and kinematics and movements, so the whole vise is going to be completely articulated and will produce a relevant and coherent addition to the kinematic calculations of your machining jobs. So to do so, we'll close this window now. First, I'm going to go up to the root of the vise here, and we are going to move this up. And we can see, as I dragged it, it snapped, so the base surface is now on the turntable surface. Now, ordinarily, in a real-world environment, I would be much more worried about lining up these bolt holes, but since this vise is not really designed for a table of this size, it's not a big deal for now. So, we have got our table here, we've got our vise here, we're all very happy with that. However, we need to constrain the jaw of the vise, and we need it to move in the correct direction, and we just want to make sure that it fully corresponds to the actual reality of the vise. So first thing we're going to do is we are going to take a look at the jaw here, and we're going to click on properties. So we can see here now we have got these properties set up here. We have a direction setting, we've got maximum minimum values, we can define it as being a linear jaw, We can also tell it whether or not we want its current position to be at 0, or all of this sort of stuff. So let's quickly work through this now. So if we just try and move the jaw around, we can't do anything right now because this properties window is open. So I'm going to close that, and I'm going to click on and try and move the jaw, and oh dear, it's moving in the wrong axis. This is not really ideal. So let's go back into properties and we'll take a look at direction, and we can see here how it's set to 1 in Y. Disregard the millimeter aspect of this. This is just a minor issue. So 1, 0 and -1 are the Boolean values that we're interested in for each of these axes. And typically that means that we can define pretty much any range of motion for any clamping face on this. However, what we would like it to do is we would like it to move to the left as we're looking at it right now, which is functionally moving in negative X. I do apologize. So we're going to set Y to 0 and X to -1. And I'm going to click on OK. And now if I click and try and move it up and down, it's not having it. If I try and move it right, it moves out a tiny bit. But if I move it left, that goes in the direction we want. But it does, unfortunately, exceed the limits of where we want it to go. So I'm going to bring this jaw back to roughly where we're looking at. And we can see here the current value of where the jaw is. And that's at 164.4, which that's a bit of a specific number. So I think we can get away with setting that at 165. Okay. So again, we're going to go back into properties and we're going to set the value at 165. And that is pretty much that. So if we've got that now, we can see, we can define our jaw, okay, our complete range of motion. And because that didn't save, because apparently I'm a bit of a fool, I'm going to set that 165, press return, and then press OK. There we go. That now snaps into place. So again, that has our jaw attributes defined quite nicely. That is pretty much how one sets up a basic vice. And in order to save it from here, we can just click on save and give it a name. So I'm going to go with Kurt, and it is I cannot remember the name of it, a DX4. So DX4. Okay. Now, were we to do something so rash as to, I don't know, delete this, it's no longer the end of the world, because we can literally just click on the drop down in load and click on Kurt DX4. Lo and behold, our vice has just reappeared with the same attributes that we've already given it. So if we move this around, we can see that that now locks into the place where it should be, and it doesn't exceed its travel in the other direction either. Which basically means we now have a readily repeatable and readily reusable vice that we can use for any future job that we see fit. So there's going to be a couple of follow-up videos to this where we're going to go into more detail about setting up other work holding options, and I hope to see you in those. Take care.